Howdy, AP PreCal. It is Ms. Kosh. This is part 2 of Mr. Passwater's notes from 2.1 on sequences. So I haven't looked at it. Here we go. You get to watch me think through this as we go. Okay, reminder, a geometric sequence has a successive term that have a common ratio. Has successive terms, sorry, that have a common ratio. This means that each term is multiplied by the same number to generate the next term. The general form is usually the best form to use. G sub n equals G sub k times r to the n minus k. Sure. Okay. So for this one, find an equation for the, I said sure because my favorite version is this. But they're the same. It's just, this is actually more general than mine, but I'm used to years and years of doing that. So anyway, however you get there is great. But I'm starting to see the benefit of using their method. Okay. This one, G sub n would be equal to G sub 3 times r to the n minus 3. Okay, so I see G sub n would be equal to G sub 3 is negative 3. R is 10 to the n minus 3. I guess we're done. So I'd be curious to see what his answer key said, but I didn't pull it up and it's not worth going to look. I typically prefer that a little more cleaned up. So what we notice here, we might be fine. If this shows up in multiple choice, circle the answer and move on with your life. However, I want to keep going. So this would be equal to a negative 3 times a 10 to the n and a 10 to the negative 3. Okay, 10 to the negative 3 means this is, okay, here's a negative 3 times 10 to the n times 1 over 10 cubed would be 1,000. Okay, so I think it might be helpful or beneficial or whatever you want to say to call this negative 3 over 1,000 times 10 to the n. Okay, that you can see a little bit more clearly what my, not my first term would be, but what my y-intercept would be, what my initial amount is. But they could give you, it might also be that you would have negative 3 over 100 times 10 to the n minus 1, whereas this is now your first term of your sequence, and then you multiply by 10 to get each subsequent term. Anyway, it's multiple choice most likely, so look and see what's available. Okay, so now G sub n is a geometric sequence with G sub 2 equals 24, R equals 1/2. Okay, G sub n would be equal to G sub 2 times R to the n minus 2. G sub n would be equal to 24 times 1/2 to the n minus 2. Once again, we've answered the question, but it might be beneficial to say this is 24 times, 1/2 to the negative 2 is actually 2 squared. And then this is 1/2 to the n. Okay, so 4 times that, what is that? 48, 96. I always have to think in terms of hours. G sub n is equal to 96 to, times 1/2 to the n. And so now we need G sub 5. Oh, okay, hang on. G sub 5, that's a 5, pretend. 96 times 1 over 2 to the 5th, 2, 4, 8, 16, 32. And I think that equals 3. Ah, clever. Okay. So what is this? Given 2 terms. Okay. Sorry. If you want to pause that and go read it, great. If not, I'll just start teaching. So G sub n be the geometric series with sequence. Sorry, sequence. They took series out of our curriculum, so I throw it in at the end of the year. But anyway, sequences. So we have, I would say G sub 6 is equal to G sub 3 times R to the 3, because this was 6 minus 3 is equal to 3, and I was too lazy to write a second step. So let's plug in what we know. G sub 6 is 128. G sub 3 is negative 2, R cubed. Okay, and so when I divide, I get that R cubed is equal to negative 64. And if you remember, we can take the cube root of a negative value. It gives us, and this would be negative, R would equal negative 4. Okay, so G sub n would equal, well, G sub 3 to the times R to the n minus 3. So G sub n would equal, G sub 3 was negative 2. Negative 2 times negative 4 to the n minus 3. That's messy, but it's not wrong. I don't know. Yeah. I don't love it. What would I do? I would probably have said, let's solve for, I would probably say g sub 3 is equal to g sub 1 times r squared and find g sub 1. And so g sub 3 is negative 2. We don't know g sub 1, but we know that r is negative 4. We square that, that's 16. When I divide by 16, I get a g sub 1 is equal to a negative 1/8. Okay, and so then I have g sub n is equal to g sub 1 times r to the n minus 1. So g sub n is equal to a negative 1/8 times r. Nope, r was negative 4. Negative 4 to the n minus 1. And that would be how I would prefer to write my answer. Then they asked me to find the, g sub 11. Oh, these are gross because they just give, g sub 11 would be equal to a negative 1/8 times a negative 4 to the 11 minus 1. And I do not expect you to know 4 to the 11th power. 2 to the 11th maybe, or the 10th, I mean, but whatever. So I see can you see my calculator? I see a negative 1/8 times, in parentheses, negative 4 raised to the 10. Make sure that negative goes in the parentheses. And this becomes a negative 131,072. All right, so I knew that would be ridiculous. There you go. Okay. Oh, you know what? No, they did want g to the 11. I started working this problem. Let's see, is this one any different? It's the second term and it's the 7th term. No, it behaves the same way. The thing that I would caution you on is if, let me just make one up that's easy. If I tell you g sub 4 is equal to 64 and g sub 6 is equal to, hang on, my brain just stopped, 256? Okay, I'm making this easy on purpose. To caution you about something. If I say g sub 6 is equal to g sub 4 times r squared, then I get 256 is equal to 64 times r squared. I intended to make that, let's just make sure I know what I'm doing. Oh, good, it is 4. I was like, they're going to comment below, Miss Kosh, you don't know anything. Okay, I do know things. Okay, so on this one, I found that r squared is equal to 4, and so this could either be plus or minus 2. And so you have two different sequences that we could find here. And so if r is positive, okay, I want to find the first term. G sub 4 is equal to g sub 1 times r cubed. So g sub 4, nope, I already know it, is 64 is equal to g sub 1, 2 cubed is 8, divide that, g sub 1 would be equal to 8. Okay, so what happens is option 1, or the sequence 1, would be g sub n is equal to a positive 8 times a positive 2 to the n minus 1 power. And so now when I plug in 4, I get, this becomes a 3, so this stays positive, and then this is positive. Yeah, so we're good there. And then I can also say, well, it's negative 8 times negative 2 to the n minus 1. Now when I plug in 4, I'm going to get a negative times of, this becomes, it's raised to the 3rd power, so 3 negatives make it negative, so it's a negative times a negative, and that's still positive, which we need right here. So hopefully that made sense. Be aware that you can take, when you take the square root of a positive, or when you take the square root, you can get both a plus or minus. I'm going to skip this one. And let's see. Oh, I printed it twice. Okay. Maybe, what is this? Oh, this is 2-2. Okay, come back for the next video. So as I said before, I didn't look at it ahead of time. Like, subscribe, comment, let me know how I can help you, and go practice.